Hello, everyone. Welcome back. Today we are going to learn about a new topic called periodic functions. So today is just going to be an introduction to periodic functions. We'll go into more detail on future days. So let's start with what is a periodic function. So a periodic function, basically, it's something that repeats the same thing over and over and over and over again. So as you can see, here's an example. This one has this wave and it repeats the same wave over and over, not different ways, this exactly the same thing again and again and again. Same with this one. Looks like it goes down, then up, down, then up in the exact same fashion. And same with this one. It goes, does a little M shape, then dips down, M shape, dips down, M shape, dips down, and so on. So basically, a periodic function repeats itself over and over and over again and never ends. So here it says, when moving along any point of a periodic graph, and the graph itself begins to repeat, one cycle has been completed. And so here's some examples. They show how one repetition is one cycle. So here, for example, this graph goes up, down, and back here, and then it does it again, up, down, like that, and then it does it again, right? So each one of those is a separate cycle, right? Every time it repeats. Or here, for example, we have down, up, and then repeat, down, up, repeat, and so on. Or here we have, this is one cycle, right? The M shape, and then it does the M shape again, so that's a separate cycle, and so on, right? So every time it repeats and starts again, then that's a new cycle, right? So each cycle of the pattern accounts for, it shows us the entire, what the entirety of the pattern is, and then we know to repeat it. The period of a periodic function is the length of time or distance it requires a function to complete one cycle. So let's take a look at what the periods are for each of these. So here we start at 0 for time, and then here after cycle 1 we end at 80. And then as you can see at 160 we've completed a second cycle, and then at 240 we will have completed a third cycle, and so on. So in this case the period is 80 seconds, meaning that every 80 seconds this graph repeats, right? Every 80 seconds, we have our distance versus time graph. It does the same thing again, it repeats itself. In the second example, we have pressure, which is pounds per square inch, versus time. So here looks like this is where the first cycle ends, and looks like same thing actually. Looks like this one is 80 seconds. At every 80 seconds, this repeats as well. This one, it's kind of hard to tell because they didn't actually label the graph, but whatever this distance from here to here is, that would be our period length, because that is how long with respect to the x-axis that it took to do one full cycle. So basically, the amount of time, or whatever the x coordinate is, that length, that distance, whatever it may be, that is the period length. So that's the way you find it on a graph. We'll talk about how to find it from like an equation, that sort of thing, in a future time. Okay, so I'm going to go through 3 examples here and how we would complete them. Example 1 says, for the graph below, find the period, draw one more cycle on the graph, and then it asks what is the next time after 300 seconds that the graph is at a height of 1 meter, and when are the next 2 times after 300 seconds that the graph is at a height of 15 meters. So let's start with one step at a time. The period we actually already just answered previously. We said that it starts at 0 and that the first cycle ends at 80. So therefore, the graph repeats itself every 80 seconds. And if it repeats itself every 80 seconds, then that means the period length is 80 seconds. So my answer is 80 seconds for that reason. Then it says draw one more cycle on the graph. I'm going to do that in black. So let's see. Looks like we have a turning point up here at 100 seconds, so 20 seconds after. So I'm going to draw that same turning point at 180, because that is at 20 seconds after. Then we have this point here where it comes back down at after 20 more seconds, which is going to be 200 seconds. Then it goes down here at 140. So after another 20 seconds, it goes all the way down there. So I'm going to draw that as well. And then after another 20 seconds, it goes here at 240 and the cycle is complete. So now I'm going to draw it. It's okay if your drawing is not perfect. Just do the best you can to make it look the same as the others, so that someone reading this would know it's the same thing, it's repeating. So there we go. I drew one more cycle on my graph. Okay, then question C asks, when is the next time after 300 seconds that the graph is at a height of 1 meter? So you might look at this graph and say, well, but there isn't 300 seconds. We stopped at 240 seconds, so how are we supposed to know that? Well, here's the thing. The graph, it repeats, right? It repeats. And so we're going to be able to figure out, based on what we've already drawn, we're going to be able to figure out when the next time after 300 seconds we get 1 meter. So first, before we can do that, we need to first figure out, well, when does the graph hit 1 meter in the time we have? I'm going to highlight those points for us. So this is 4, so we want about halfway up, so right here. Here, here, here. So basically, it does this at 60 seconds, and then every interval that is equivalent to that in our graph, right? So because the period length is 80 seconds and the graph repeats itself every 80 seconds, that means that we could go up any number of 80 seconds or down any number of 80 seconds and we would still get the same thing. For example, if we go up by 80 once, we get to 140, right? Because the graph repeats itself. And so, going up by 80 seconds gave us the same point. We could go up by 80 seconds again and get 220, right? And then we could go up 80 seconds again and get 300, but they wanted to know the next time after 300. And then we could go up another 80 seconds on the fifth cycle and get 380 seconds. So that's the answer they're looking for, 380 seconds. Right? Because this graph repeats every 80 seconds. So by finding out, okay, on the first cycle it's 60 seconds, and then just adding 80, adding 80, adding 80 as many times as we want until we get to the results we're looking for is a good way to go. Right? Because in terms of, in general, when are we going to get to the height of 1 meter? It's going to be 60 plus 80k, where k is any integer, right? This represents all the infinite many times that this is going to occur. Now, in this case, they just asked for one value. They didn't ask for this. They just asked for the one value, 380. However, this equation, if you were ever asked, state all the times that this graph reaches 1 meter. Well, the thing is, to try and list all of them, that would be impossible. You'd never stop writing things because there's an infinite many. So what they would expect is a general equation like this. They don't really expect you to list out all the different times, because that would take quite literally forever, and so that wouldn't really be possible. Okay. Let's move on to D. It asks, when is the next, or I guess they should say, when are the next 2 times after 300 that the graph is at height 15 meters? So first of all, when on the first cycle is the graph 15 meters? Oh, I lost this. That's okay. I'm going to write it back in. Well, let's see. 15 meters. That's the very top, I believe. Yeah, 14, 15. Yeah, that's these very top ones here. So this happens after 20 seconds in the first cycle, which means that in the second cycle it would happen at the 100 mark, right? Because 80, every 80 we get the same thing again. Then what's 100 plus 80? Well, that's 180, so that's when it would happen again. What's 180 plus 80? That is going to be 260. And then, okay, well, that's still not close to 300. So what's 260 plus 80? Well, that's going to be 340. So that's our first answer, is 340. But they want the next 2 times. So when's the time after that? Well, we got to add another 80. And we're going to get 420 seconds. So those are going to be our 2 answers. Now, again, there's infinitely many, and if they just wanted the general equation, or if they wanted to know all the times when the height of the graph was 15 meters, we could say, well, it's going to be 20, because that's how much it is in our first cycle, plus 80, because that's our period length. It repeats every 80, times k, right? Whatever k is, whether it's a billion, whether it's negative 10, whether it's just plus 1 just to get to this one, whatever it is is going to work so long as k must be an integer, right? K can't be a fraction or something, but as long as k is an integer, then we're okay. Very good. All right, so let's try another example. We still have two more examples like this today. And I encourage you to pause this and actually try this on your own first, see if you can figure it out, and then come on back when you're ready. Or if you get really stumped, you can come back because there will actually be one more opportunity to do the same thing. Okay, for the graph below, find the period, draw one more cycle on the graph. When is the next time after 250 seconds that the graph is at the height of 60 psi? And what are the next two times after 250 seconds that the graph is at a height of 120 psi? So let's do it. First, let's find the period. So how long does it take to do the cycle once? Well, we actually already answered this on the last page that it's going to be 80 seconds. So my answer is the same as last time. It's 80 seconds. And I just want to say it's just a coincidence that both of these are 80 seconds. That's not some common thing to put necessarily. It just happens to be for both of these examples we've done so far. Then it says to draw one more cycle on the graph. So I notice in this cycle of the graph, we go from 0 to 60. So we need to go from here, from 160 to 60 more than that. So what's 60 more than that? 60 plus 160 is 220. So we need 220 and our lowest point there. And then the next 20, we go back up. So we know these are our points that we're going to do. And then I'm just going to draw as straight as I can those two lines like that. Good, so there's my one more cycle on my graph. The key thing here is just make sure that it's exactly the same as the other cycles on the graph, and then it should be good to go. That's really the only requirement there. Letter C asks, when is the next time after 250 seconds that the graph is at a height of 60 psi? Well, first of all, we've got to ask ourselves, okay, on the first cycle, when are we at 60 psi? Well, right here, 60 psi actually happens to line up with 60 seconds. Then the next time is going to be 80 after that, right? Because remember, the graph repeats every 80 seconds. So 60 plus 80 is 140, plus 80 again is 220, and so on, right? So then what's 220 plus 80? Well, that's 300. And so that's going to be our answer, 300 seconds, because that's the first answer we get that's above 250. And so there we go. Voila, that's the answer. Okay, this next one asks, when is the time? And actually, I'm going to highlight this in purple and I'm going to highlight this one in blue. When is the next time after 250 seconds that the graph reaches a height of 120? Well, when do we get to 120? We get to 120 basically at the beginning and end of each cycle, right? It's there at 0, it's there at 80, then at 160 at the end of cycle 2, then at 240 end of cycle 3. And the end of cycle 4 would be 80 after that. So that's going to be 320. So that's our next answer, 320 seconds. And then it did say the next two times after. So when's the next time after that? Would be another 80. So that would be 400 seconds. And there we go. Voila. All right, well, that's actually going to be it for today because this next one here, they actually didn't give us dimensions, so we're not going to do this one. And also, this one really doesn't look like anything like the sinusoidal functions that we actually care about throughout this unit. So I'm not going to worry about this next one. But yeah, I think we did two really good examples. I will say, out of all the examples we did, example 1 is probably the best example and most closely resembles the types of problems we're going to be doing throughout the rest of this unit. So I will see everybody next time when we talk about the transformations of this type of function and how to graph this type of function. So good work, everyone, and I will see you next day for that. Bye, everyone.